Okay, welcome to lesson 5.3, graphing rational functions. We're going to use some of the ideas that we learned in the investigation for 5.2 and put them all together so that we can graph rational functions. We're going to be able to find the intercepts, the holes, the asymptotes of these functions, and then we'll find some other points if there's some empty sections of the graph to help us be more clear. So a definition, a rational function has the form f at x is equal to some function p at x divided by some function q at x, where p at x and q at x are polynomials and q at x can't be equal to 0. All right, so our tip for these questions is to start always by factoring. So we're always going to start there, and then we're going to find holes, then use the function that's left after you cancel for the rest of the question. The instructions for example 1 are for each function state the x and y intercepts, the holes, the equations of the vertical and horizontal asymptotes, and the existence. So just yes or no if there's an oblique asymptote. And then we'll sketch the graph. All right, so starting with x-intercepts, we know that for x-intercepts, we just set the y value equal to 0 and then solve. And what you're going to notice every time you set a rational function equal to 0 is that you're just going to take that denominator up to the other side and multiply it by 0. So you're going to have 0 times the denominator equals the numerator. That every time that's going to give you 0 equals the numerator. Only the numerator will give you x-intercepts. So now I'm just going to solve, bringing the 1 over and subtracting, and then bringing the 2 over and dividing it out. So x is equal to 1/2 is my x-intercept. So for y-intercepts, we're going to set the x value equal to 0. And then we're just simplifying. In the numerator, we get 0 plus 1, and in the denominator, 0 minus 2. And of course, to simplify, we always pop the negative up to the top of a fraction. So the y-intercept is actually the same as the x-intercept. So my y-intercept is also going to be negative 1/2. Oops. All right, the next thing it asked me for were the vertical and horizontal asymptotes. So I know that for my vertical asymptotes, I'm always finding the zeros for the denominator. Right, my vertical asymptote is always going to be what can't you divide by? Well, you can't divide by 0. So just setting that denominator equal to 0 and solving, it says that there's going to be a vertical asymptote at x equals 2. For the horizontal asymptotes, I look at the degree of the top and the bottom. We just looked at this in our investigation. So the degree of the top here, 2x plus 1, the degree is 1, and the degree of the bottom, that's x minus 2, so the degree is 1. And so I have matching degrees. And remember, this was the trick where I say that y is the lead coefficient of the numerator divided by the lead coefficient of the denominator. So for me, the lead coefficient of the numerator, 2x plus 1, so the lead coefficient is 2. And on the bottom, it's x minus 2, so the lead coefficient is 1. And so my horizontal asymptote is going to be at y equals 2. All right. The next thing that they asked me to do is just sketch the graph. So when I do this, if I don't have enough information on both sides of my vertical asymptote, I will come up with some extra points. And I can tell already that I don't. When I'm planning my scale here, I'm looking for, well, what x values do I care about? I care about x equals 2 and x equals 1/2 and x equals 0, or those are the 3 x values I have so far. Both of these points are on the left-hand side of my vertical asymptote, x equals 2. So it tells me I am going to have to find a couple of points on the right side of my vertical asymptote. So I'm just thinking ahead, I'm going to find 2 points on the right side of my graph. And I'm only doing that because I don't have any so far. I want to have at least 2 points in each section of my graph, and I'm talking about the going across the x values when I'm talking about sections. So I'm going to find 2 points to the right of 2. I'm going to pick 3 and 4, but you can pick other things if you want. So I'm just plugging 3 into the equation. And I'm plugging 4 into the equation. But again, you could have picked 5, you could have picked 6, you could have picked a fraction if you like. All right, and so if you want to be thinking, because we're graphing, so you could be kind of thinking about that as in decimal form instead of fractional form, if that helps. All right, so this helps me plan my scale. So now I know all the x values I want to see. The biggest x value I want to see is 4, and the smallest one was -0.5. So thinking about that for my x-axis, thinking about my y-axis, the biggest, so here I had y equals 0, then I had y as -0.5, then I've got y equals 2, and here I've got y equals 7 and y equals 4.5. So I need to be able to see up to 7. So I'm going to draw in my axes. We're seeing lots of positive y values all the way up to 7, but I only need -0.5. And then lots of positive x values as well, because I need to see over to 4, but I only need to see -0.5. So I'm going to see up to 7 and definitely down to -0.5. So here I could actually count every 4 squares as 1 for my x-axis, because I know my last point is going to be at 4, but I'm going to just keep it the same as my y-axis. All right, so now I'm just plotting the points and plotting the asymptotes. So I'm going to start with my asymptotes. I have a horizontal asymptote at y equals 2, and I have a vertical asymptote at x equals 2. And that's just coincidence the way that this equation is set up. If there were different numbers, that would not happen. They would be matching. And now I'm going to start plotting some of my points. So I know that my x-intercept is at, -0.5. My x-intercept is at -0.5, and my y-intercept is also at -0.5. So those are my 2 points in that quadrant. Over here, we figured out 2 points onto the left or to the right of my vertical asymptote. We set at x equals 3, y is 7, and then at 4, the y is 4.5. And so I kind of have a picture of what my graph is going to look like. I'm going to get closer and closer to that vertical asymptote, and then closer and closer to the horizontal asymptote. And then same thing on this side here. All right, and we're all done that question. Moving on to the next example.